Ladies and gentlemen, please welcome once again Dr. Rachael Livermore to the stage. Is yours working?
I don't know, is mine working?
Hooray! Wonderful. I mean, to me that movie is perfect. I don't know how there could be anything wrong with it. They shot it in space, you know.
Yeah, that's true. So I don't normally drink alcohol at these screenings since I have to get up and speak, but today I did. Made that last act make way more sense.
Hey, it's better than Interstellar, so.
So, true story, they wanted me to do Interstellar today, and I said no. That's why you got this one.
Chris Nolan really likes this movie, though, so maybe the law.
Well, there you go. But you know who doesn't like this movie, or didn't like this movie? Arthur C. Clarke.
Read the book. That's all I'll say about that. Read the book. Anyway.
So this film tends to be extremely divisive. Film buffs like Max here love it. Sciencey literal people like me do not. So I'm going to be upfront and say I do not like this movie. I love the book. If you were iffy about this and you haven't read the book, go read the book. It has plot. It's great. No offense to people who like this movie. I'm glad there are people who like it because it gives me an excuse to talk about science. And despite not liking this movie, I have watched it twice now in the space of a week, just so I can talk about science, because that's how much I like science. So let's dive into the science of this movie. This is one of the best science fiction movies in terms of the portrayal of science. You could almost believe that it was filmed in space, but not quite. One of the things it does really, really well is something we've talked about a lot if you've come to a lot of these screenings, is gravity, as in the force, not the movie. The force of gravity is portrayed really, really well in this movie. You may have noticed on the space station that we see near the beginning of the film, we have this big, spinny, rotatey thing. So this is providing artificial gravity on the space station, and it does it through a centrifugal force, where if you're within that ring, you're being pushed to the outside of it, so you feel a downward force where down is in the direction pointing out of the ring, which is a really cool way of being able to film a space movie on Earth where there's gravity. And also, I guess if you're doing space travel for a long time, having gravity is useful because then your muscles don't waste away and stuff, which is nice. This is also a technique, and again, if you've come to a lot of these screenings, you will recognize this from The Martian. This is another movie that used the same method to give artificial gravity on a long space mission. And it gives you these really, really cool effects where down is different depending on where you are. So we saw people running around the outside of the spaceship, which was really cool. And on the shuttle though, when they're on the way to the station, there is none of this artificial gravity. So they use these cool Velcro shoes to walk around. Which is pretty neat, a way of sticking to the floor when there's no gravity. Now, honestly, the way she's moving around isn't quite right for someone walking in zero gravity, but you have to bear in mind, at the time this movie was being made, no one had actually really seen people in zero gravity. People had only been up into space in tiny little Gemini capsules, so today we're accustomed to seeing video from the International Space Station. This was a pretty good guess for someone who had never actually seen it before. And it gives us really, really cool scenes, like this really famous one, where our air stewardess, whatever she is, gets to walk around a complete circle. Now, this isn't really necessary in terms of physics. If you have zero gravity, you could just detach yourself from the Velcro and just kind of flip yourself around and go upside down. But then we wouldn't have this really cool long take of her walking around an entire circle upside down. So, what are you going to do? You can only be so accurate. And I really like this, where the camera kind of flips around and reasserts what down is according to where she is right now. It's really cool. One other thing I like is the head covering she's wearing, which I'm going to guess is because if you have longer hair than all the men in these scenes, you're really going to be able to tell that there's gravity. So you may as well cover up all the hair, makes it easier if you can't see what's going on. Now that said, the gravity in this movie is not depicted perfectly. This is going to be super nitpicky, but watch what happens to the liquid as he drinks from this straw. Now, if you didn't see it, I'm going to show it again in slow motion with a little arrow. Do you see the liquid going back down? That's gravity. So this is how nitpicky I have to be with this movie. It is not perfect. In this same scene, something else really, really weird happens to that same food tray, which I really, really don't get. So he's holding it, he lets it go, he's chatting to this guy, and then, whoops, what happened there? So there is not really zero gravity in this space shuttle. One of the things we discussed month before last is Einstein's equivalence principle, which tells us that acceleration and gravity are indistinguishable from each other. Now this shuttle is traveling between things that are in orbits, which means at some point it has to accelerate, and so there will be forces. So there are situations in which a tray could do that weird thing if there's suddenly a thrusting motion coming out of the spaceship, but then you would see other things being jerked around as well. Not just the tray, the people would have kind of gone, oh, as well. So I have no idea what's going on there. But you see this a lot in movies and TV shows that try to do zero gravity, that as soon as the gravity stops, they'll just suddenly float upwards. You don't go upwards, there's just nothing pulling you down, you just kind of stay where you are, unless there's a force acting on you, that is Newton's laws of motion. So I like to talk about Newton's laws of motion because it's the most basic physics you can do, and movies still get it wrong. Now this movie actually gets it pretty right though. I really like this scene because I'm soulless. You see there was an initial force acting on this guy and his pod, and they're spinning around, and because there is no air in space, there's no air resistance to slow you down, they're just going to keep traveling and keep spinning forever and ever and ever. Now, if you were here in April, this scene may have reminded you of something from a more recent movie, Gravity, where pretty much exactly the same thing happens. Whoa, she goes spinning off, and she's spinning, and she's spinning, and she will never ever stop unless George Clooney comes and intercepts her, which luckily he does. Now, this movie is almost entirely set in space, and so it deals with a lot of very, very, very basic space things, some of which are a little bit iffy. One thing you may have noticed if you've seen any photographs from the moon is how dark shadows are. So let's talk for a moment about how shadows work. If you have a single source of light, as I do right now, with a spotlight up there, your body is going to block some of that light from reaching the ground. And so that's why you get a shadow behind you. Now on Earth, the shadow is not going to be completely black because the air scatters light. That's why if you look at the sky during the day and you're not looking directly at the sun, which hopefully you're never looking directly at the sun, the sky still looks bright, even in the opposite direction. That's because light from the sun is hitting particles in the atmosphere and they're scattering it around. And the same thing happens to kind of lighten your shadow. As the light comes past you, some of that air is going to scatter it and it's still going to fall behind you. And that's why shadows are grey, not black. On the moon, though, there's no atmosphere, so shadows are pretty much completely black. You can't really see anything in shadow on the moon. Which makes some of these shots in space a bit interesting. Now, spaceships, unless they're being directly lit, should be invisible. They should be completely dark. Now this one, we're within the solar system, so there is a source of light, the sun, which, judging by this, is over there somewhere. But this side is in shadow, and that should be completely black. Now it's not for artistic reasons. Obviously someone went to a lot of trouble to make a model of this spaceship, and they want you to see it. So hence the shadows are a bit grey. But again, I'm being very nitpicky. A couple of other weird things in this scene. In fact, every scene that's set in space, an external view of a spaceship, you notice the stars in the background are twinkling. You probably didn't notice, in fact, because you've always seen stars twinkle. That's what stars look like. It's actually not what stars look like. Stars don't twinkle. The twinkling effect is caused by distortion of light in our atmosphere. It's a pain in the ass to astronomers because it distorts our images, and that's why we put telescopes in space. So if you're in space, without any atmosphere doing this distorting, the stars shouldn't twinkle. You also, if you're being a super nerd, might notice that the stars disappear a little bit before the spaceship covers them up, which is because the rotoscoping is not very good. I think it was actually slightly deliberate, because who's going to notice that, right? No one's that nerdy. That said, I fully admit that I am being extremely nitpicky here, because one of my favorite things in space is this guy. And this is in deep space. There's no sun lighting up the Enterprise, and look at all that light. So it's not like other movies don't commit the same errors, even worse. So another thing that a lot of movies cover is what happens to you in a vacuum. And I have to give some props to this movie. It does the vacuum pretty well, in that he doesn't explode. If you've seen Total Recall, they do like the eyes bugging thing, which is really weird. So this doesn't do that. What he does instead is he takes a really deep breath, holds that breath, and then blows the hatch. Now, one question I have here is, what happens to that hatch door? It's blowing out, it should come here, it just vanishes. It's really, really clever. And I guess kind of fortunate, because it would hit the camera and then you wouldn't see the guy. But there's a problem with holding your breath. Your lips are not completely airtight, and also holding your breath is pretty much the worst thing you can do in a vacuum, because then your lungs are going to be full of oxygen, and in a vacuum that's going to expand, it will probably perforate your lungs or something. That's a really bad idea. The best thing you can do is empty your lungs completely. You use up the oxygen that's already in your blood in about 15 seconds, after which you pass out, and then you'll die maybe a couple of minutes later. Fun. So this is fairly reasonable. A lot of movies have this idea that as soon as you're exposed to a vacuum, you explode, the end. And that's not true. You can actually survive for a couple of minutes in a vacuum. I just really, really don't recommend it. So the monolith. This is a thing that plays a major role in this movie. The movie does not attempt in any way to explain what it is. It's just a thing. So we see it here on the moon. And I took the sound out of this clip because, ouch. But it emits this really, really high-pitched sound. And the movie only explains right at the end, when Dave gets that automated recording, that it's actually transmitting a signal towards Jupiter. I have questions about this. And this is something that only really comes up if you've read the book, because the book makes it very clear that lots and lots of experiments were done on this monolith, and it appears to be completely, they can't open it, it appears to be completely uniform density. There's no like moving parts or anything inside. It's just a completely solid, inert monolith. But it's pointing a signal at Jupiter. So how does the solar system work? Here's the solar system. The planets all go around. When you see a like kid's poster of the solar system, the planets are all in a line, but they don't live like that. The planets are all moving different speeds because they feel different amounts of gravity from the sun. The closer you are to the sun, the higher the force of gravity you feel, and so the faster you move. So the inner planets, like the Earth, are zipping around really fast. The outer planets, these distances are not to scale. The outer planets are much further out than that. Also, they're much smaller, but that would be boring. You wouldn't be able to see them. The outer planets are moving much more slowly. That means sometimes, like here, the Earth is pretty close to Jupiter, not that close. And at other times, like coming up here, is going to be completely the opposite side of the sun. In other words, Jupiter could be in any direction. So somewhere in that monolith is a computer that knows the exact time and date, and knows the exact position of Jupiter relative to the moon at that time, and can point its signal directly at it. Now again, this is not necessarily a mistake. The aliens who created this monolith are obviously way more advanced than me, and presumably they know how to do this without any moving parts. I'm just saying I have questions. So I like to talk about the moon a lot, because the moon is something we're all really familiar with, and it's amazing to me how many movies get it horribly wrong. Even movies that are kind of about the moon, as we'll discuss. So one thing that this movie does correct, here is the moon. It's not surprising they did this right. I mean, Arthur C. Clarke was working on it. We learned that the monolith was buried at the Tycho crater. It's a real place. Tycho crater is right down there. It's the most prominent crater on the moon. And that's where my positive comments about the moon in this movie end. So this next clip is the only one that I left the sound on, and it's well, the only one I left music on, and it's necessary because the pretty Strauss waltz distracts you from some really, really terrifying physics. Does anyone spot the terrifying physics? It's to do with the phases of the moon. So this is something that I think is really obvious, but my experience of teaching undergraduates has taught me that not everyone thinks about it. The phases of the moon are fairly simple geometry. If we picture a world where we're in the Earth's reference frame, so the Earth is stationary, the moon is orbiting around the Earth. In this picture, it's going counterclockwise, and the sunlight is coming from this side. When you're really, really far from the sun, the light rays are effectively parallel. So we have parallel light rays coming from the sun, going past the moon or the Earth, and out the other side. So the phase of the moon takes a full month to cycle through. Anyone on the Earth on one given night will see the same phase of the moon. Now let's say it is midday where you are. That means you're on the bit of the Earth up here, pointing directly towards the sun. If the moon is directly overhead at midday, your local time, it is going to be a new moon, so you won't actually see it. So let's say it's sunset. This means you're on the edge of the terminator, like at the top of the Earth in this picture. If the moon is directly overhead, it's going to be a first quarter. Now, so if you see a moon overhead at sunset, it is always a first quarter. Now, the sun at that point is setting, so you'll see the sun over on the western horizon. If you look over on the eastern horizon and you see the moon rise, it's going to be a full moon. If it's midnight and the moon is directly overhead, it's a full moon. This is always true for your local time wherever you are. Not exactly, because time zones are, they don't have any physical meaning, but roughly. So if you're on this side of the Earth and you look directly up and see the moon, it's full. If you see a full moon in the day, something really, really weird has happened. So the reason I said that previous scene was terrifying, you may have had a clue as to why if you were here for our screening of Apollo 13, where we had this scene where you look out of one window and you see a full moon, and then same scene, we look out the opposite window and we see a full Earth. This is terrifying because it means that the sun is positioned exactly halfway or in between the Earth and the moon. That's kind of apocalypse time. And so what we saw in that scene at the beginning of this movie is a full Earth, and you look up to a full moon. That means the sun is in between them, so frankly, I don't care about this monolith. The world's ending. There are also some weird moon phases going on as we're landing on the moon here. You're looking at the Earth. So phases of the Earth work the same way from the moon as phases of the moon work from Earth. And it should take a full month to change. So here, this is a waxing gibbous Earth. But here, we're watching the same landing from these guys' point of view. We have a waning gibbous Earth. So this is 2 weeks apart. Now, I know that scene felt long, and that's why. Oh, now here, as we're digging up the monolith, notice we're back to a waxing gibbous Earth. So this is another 2 weeks later. This is the kind of thing that if you start paying attention to in movies can drive you crazy. I only actually noticed this time, watching it on a big screen for the first time ever, that in the Dawn of Man sequence, the phases of the moon are completely wrong. It's either sunset or sunrise, it's pretty unclear, and there's a very, very thin crescent high in the sky. That's impossible. And you see this all the time. Lots of movies like to show full moons rising over the horizon because it looks pretty, but they'll show it in the dead of night. That's impossible. The full moon rises at sunset. So again, don't pay attention to this. It will ruin every movie. So since I've been a little bit critical, I wanted to finish with some random things that make me happy in this movie. And this is one random scene.
Oh, wait a minute. I gotta make a couple of phone calls. You go on ahead in the restaurant. I'll meet you there.
Right.
So I was 8 when I first saw this movie, and I remember this scene because I remember thinking, oh cool, one day payphones will have video. Little did I know, one day we would abolish payphones because we'd be able to walk around and FaceTime with our friends from wherever we are. It's pretty cool. I do like it when really like crazy futuristic technology in movies gets overtaken. It's pretty neat. Now this is another scene that makes me happy for multiple reasons.
3 weeks ago, the American spacecraft Discovery 1 left on its half-billion-mile voyage to Jupiter. This marked the first manned attempt to reach this distant planet. Earlier this afternoon, the World Tonight recorded an interview with the crew of Discovery at a distance of 80 million miles from Earth. It took 7 minutes for our words to reach the giant spacecraft, but this time delay has been edited from this recording.
So multiple reasons this makes me happy. First of all, he's watching that broadcast on BBC 12, and sure enough, these days there are a seemingly infinite number of BBC channels. Second of all, they thought in the year 2001 people would still be speaking in BBC English. That makes me happy. Also, they predicted vertical video, which is an abomination as far as I'm concerned. But the main thing that makes me happy about this is they acknowledge time delay. At this point, they say they're 80 million miles from Earth, which is indeed 7 light minutes. So it takes 7 minutes for the transmissions to go back and forth. Now, I have no reason to believe this is true, except in my head, I am certain someone had a conversation with Stanley Kubrick and convinced him to cut out those 7 minutes, because it seems like the kind of thing he would do. But knowing that they were actually having the conversation in that interview with 7-minute delays between responses, those first few questions are so inane. It's like, how's it going? Good. Can you imagine that with a 7-minute break in between? Oh my God, they should do some media training with these people. But the main thing that I think this movie portrays really, I was going to say well, accurately, is how slow and boring traveling in space would really be. And I'm going to use this shot as an example. This single shot is 45 seconds long, and all it does is turn the pod around. Oh my God, this is so boring. I'm sorry to people who love this movie. It's great, really. But this is precisely why I give some allowances to movies that take a few liberties with physics in the name of entertainment, which brings me to our next screening. Go. Which I wrote next month out of habit. It's actually in 2 weeks. We're doing Star Trek First Contact for a very special occasion, which is the 30th anniversary of Star Trek The Next Generation, which is actually in September, but as we hinted at in the pre-show, I'm leaving the country very soon, so we had to squeeze it into August. So let's pretend August 29th is September, okay? We'll be right back here in 2 weeks. Tickets went on sale today, and because I was doing this tonight, I didn't announce it on social media, so if you want tickets, you can get them before I tell anyone else, and I'll send an email out tomorrow. This is going to be really fun. Since I'm leaving the country, this is going to be the last movie screening I do with the Alamo Drafthouse, so I hope to see lots of you there. And I want to thank you for coming out tonight, sitting through this movie with me, and listening to me rant about it. Thank you very much to the Alamo Drafthouse for hosting these. They are really fun. Thank you to Brian, who's been recording the talk tonight for people who couldn't be here. Thank you to Max for hosting with me, and thank you most of all to all of you for coming out. If you have any other questions about science, Or if any of you are on drugs and you want to explain that last act to me, then we'll be in the bar downstairs. Come hang out, chat, and I'll see you in 2 weeks. Thank you.